you, ladies and gentlemen? We got an awesome Q&A week, a lot of questions day to day here, so I'm going to try to get through a lot of them, get you those answers that you need to meet the demand of concrete, saving the world with all the concrete in it. This one is about dry packing. Dry packing, I first learned about it on working on the Denver Spire structure back in 2006, 7 time frame-ish. I was working on a self-consolidated concrete by Lafarge, North America, called Agilia. Had a 28 to 32 inch spread. Thank you, Haley. 28 to 32 inch spread, diameter. 3/8 inch pea gravel, 28 days. It had about 5 to 7,000 psi. Great mix. But the problem with the mix is severely sensitive to segregation. What I mean by segregation, paste will pull away from aggregate. Aggregate over here and cement paste over here in your formwork. And with an SCC, it's more sensitive because you have a higher dosage of high range. You might have a low water cementitious ratio, but because you have such a high range amount as well as a high paste content, the overdosage of high range water reducer or small additions of water can lead to that paste becoming too fluid to contain or hold that aggregate within suspension. So the reason why I'm defining all of that and really need to get back to the dry packing is to understand dry packing, you have to understand the separation of paste and aggregate. And one of the ways that I saw it was using SCCs in practical levels. We really didn't understand SCCs and how just the high range affected the water content. And that leads into a project that we're starting next week on segregation sensitivity, and we're doing a whole experimental thing, right?
Yep.
Awesome. Stay tuned. So dry packing. The first time I saw dry packing, I was working on this job site, Spire structure, working on the foundation, big mat foundation. I think it was like 10 feet thick, 40 by 40, a whole bunch of steel. The congestion was just so real. Oh, the congestion of steel was horrible. So we're using this SCC, and my job was to stand in front of the liquor store and the strip club and dial in trucks, 2 trucks at a time, and then they would go to their representative hoppers for their boom pumps, and they would totally discharge as fast as possible so we can keep the what's it called going, the recurring work program going. There was one truck, I'll never effing forget it. One truck, I was trying to move fast, and I could tell based on pulling the concrete back onto the fins and it rolling over the fins if the truck was bad or not. And I mean, the truck looked great. And the driver said, "Hey, I'm gonna wash down my fins with a little bit of water. Is that okay?" And I said, yeah, that's fine, get out of here. Because I was trying to get the next truck. My fault. I totally take blame for it. I should have said, no, don't wash nothing until all the concrete is out. You can wait 10, 15 more minutes. But I didn't. And he washed down, and it all went to the drum, and that mix blew the F up. And what he did is he still let that mix go into the hopper, and nobody was checking the hopper. It was a fast job site. The techs were only taking samples from the hopper, but until somebody went there to take a sample, you didn't see it. And they were taking samples between the middle part of the truck, the middle 15 to 85% of the truck is where they were getting samples from. So he was discharging into the truck. They backed it up, they threw the chute into the hopper, and that was it. He released. And you got all this mix going to this piston-driven system, and it basically pushed all the rock ahead. The paste fell below, or fell behind, and you had this packing of material. And I guess the last piece of describing this will bring everything together. This can happen with too wet of a mix, and it can happen with too dry of a mix. And when it comes down to it, whether you're using an auger system or a piston-driven system, pumping concrete is a very simple concept. You're taking a slug of concrete, and with a little bit of extra paste that lubricates that system, you're sliding it down a tube. And it's just an infinite amount of slugs connected with that necessary amount of paste behind it. Now, If you separate the paste and the aggregate, so you got nothing but aggregate over here and nothing but paste over here, you're gonna have that dry packing or that clogging, and I'm not talking about the Dutch wooden shoes dance. I'm talking about a congestion of materials at a localized point, sometimes at a bend, but it could be in the pipe of your aggregate that stops that flow. And that's basically what happened. Because we had that segregation well before it hit the boom and it happened in the hopper, we were getting segregation in the pistons, and we weren't getting that slug of consistent concrete with the lubrication or the paste around it to move down the line and get the continuous ones to make that infinite amount. Now it can happen on the reverse side with you drive a mix if we just don't have enough paste. And basically what happens again, if there's not enough paste, it can happen because of the friction that you have in the tube, or even at the bends in the pumps, depending on what type of your pumping system you have. Anytime there's a bend, there's going to be a chance for more head friction or head loss because of that bend at 90 degree or 45 degree or whatever degree, and that's normally where you get that segregation. So again, it can either happen with too fluid of a mix, too dry of a mix, but you need that pumpable, flowable, consistent mix that can go through those bends, lose some of its slump, but still maintain a fluid enough and creamy, dreamy enough nature to get all the way to the point where you want to pump it to. So yeah, hopefully answer your question. Don't forget to let us know your concrete questions and concerns. Like and subscribe. Ding the bell. Are we doing any like giveaways this month?
Sure. I'll think.
Haley will think.
Stay tuned.
Stay tuned. Go concrete! Beat asphalt!